Hello and welcome back to e-sipnayan. For today's video, we're going to discuss how to graph a parabola. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. The only learning objective for this video is, at the end, you should be able to graph a parabola. So we start by identifying the steps on how to graph a parabola. The first step is to identify the orientation, and we discussed last time the 4 different orientations of a parabola. Next is to plot the vertex, and the vertex is plotted by identifying h and k, similar to a circle. So again, h is the constant associated with x and k is the constant associated by y. Next, after plotting the vertex, step 3 is to plot the focus. And we plot the focus using the value of p. That's why we first discussed how to solve for the value of p. For steps 4 to 7, these steps are interchangeable. But in this video, I will be following the order or arrangement of steps based on the given. So step 4 is to plot the directrix using again the value of p. Then plot the endpoints of the latus rectum. This time the measurement that we needed to know is 2 times p or 2p. Step 6 is to simply draw the curve. To draw the curve, the points that you're going to connect would be the vertex and the endpoints of the latus rectum. And lastly, you draw the axis of symmetry. Again, steps 4 to 5 are interchangeable. It will be based on your preference which part of the parabola would you like to graph first. But for the purpose of discussing this video, I will be following strictly the steps given in this slide. So before we formally begin with graphing, it's best to be familiar with this mnemonic. So we have here Hoy-Books. H here pertains to a horizontal line similar to this red line you're seeing here. What do we mean by O? It means that the slope or m is equal to 0. We know that all horizontal lines has slope of 0. And lastly, y here pertains to the y variable. So meaning, when you represent a horizontal line using an equation, we will be using the y variable, and it will always be in this form: y is equal to a number or a constant. So this is the first mnemonic that you need to be familiar, Hoy or H-O-Y. The next mnemonic is VUX or VUX. V here pertains to a vertical line similar to a blue line illustrated here on this portion. U here pertains that the slope is undefined. And lastly, x here pertains to the x variable. So meaning, when you see a vertical line, to represent it as an equation, you will be using the variable x. And the format will be like this. The equation will always be x equals a number or a constant. So why do we need to study Hoy-Books? It's very important to know how to name lines, specifically the horizontal and vertical lines, because you'll be encountering in graphing a parabola these kinds of lines, specifically for the parts directrix and axis of symmetry. Before we proceed with examples on how to graph a parabola, let's first practice applying the concept of Hoy-Books. So through this activity, you'll be able to master naming horizontal and vertical lines, or naming them using equations. So say for example, we have this given parabola that opens upward. The directrix is the horizontal red line. So to name this, since it's a horizontal line, we are going to use the mnemonic Hoy. It's a horizontal line. Never mind the middle letter. We already proceed to the last one. So since we are using the mnemonic Hoy, y variable will be used. And what is the value of y? It is the value where the horizontal line intersected along the y-axis. So this horizontal line intersected exactly at -2. Hence, if we name this horizontal line or the directrix, that will be y equals -2. Again, why y? It's because it's a horizontal line, and the variable used to name a horizontal line is y. Y -2 because the horizontal line intersected at -2 along the y-axis. Next, how do we name the axis of symmetry. The axis of symmetry here is represented by the broken blue line. And since it's a vertical line, we refer to the mnemonic VOOX. So it's a vertical line, hence we're going to use variable x. And what will be the value of x? It will be the value along the x-axis where the vertical line intersected. So obviously, this blue vertical broken line intersected at exactly the origin where the x value is 0. Hence, we name the axis of symmetry as an equation x equals 0. Why x? Because it's a vertical line, so we are going to use variable x. Why 0? Because 0 is the x value the vertical line intersected along the x-axis. Next, let's have more practice identifying the equation of the directrix and the axis of symmetry. So for this example, it is again a parabola that opens upward, hence the directrix is still a horizontal line. To name this, we refer to the mnemonic y. So we are going to use variable y. Equals to what? Equals to the constant where the vertical line intersected along the y-axis. And in this case, if we observe the path of the horizontal line, it will intersect exactly at -6 along the y-axis. Therefore, we name the directrix as y equals -6. How about the axis of symmetry? The axis of symmetry is represented by a vertical line. So since it's a vertical line, we refer to the mnemonic VOOX. So we use variable x equated to a constant. And what is that value of a constant? It will be the value along the x-axis where the vertical line intersected. So again, let's observe the path of the vertical line and notice that it will intersect exactly at +2 along the x-axis. So the axis of symmetry should be named as x equals +2. Let's have another example, this time a parabola that opens downward. So since it's a parabola that opens downward, the orientation of the directrix is also the same with the parabola that opens upward, which is a horizontal line. So again, since it's horizontal, we use variable y. And what is the y value? Let's check which part or value along the y-axis it intersected. And obviously, it will be here at +2. So the name of the equation of the directrix is y equals +2. Moving on to the axis of symmetry, it's still a vertical line since it's a parabola that opens downward. And then it will be, or we will be using rather the x variable. What will be the value of x? It will be the x value the vertical line intersected along the x-axis. And obviously, it will be here at -2. Therefore, we name the axis of symmetry as x equals -2. Let's have one more. This is now a parabola that opens to the right. So notice that the directrix is now the vertical line and the axis of symmetry is now the horizontal line. We will still apply the same concept in naming the lines. So let's start with the directrix. It is a vertical line, therefore we use the mnemonic VOOX. This vertical line. So we use the x variable and the value of x is -4 because this is the value where the vertical line intersected along the x-axis. So the name of the equation of the directrix is x equals -4. Moving on to the axis of symmetry, it's now a horizontal line, so we refer to the mnemonic y. We now use variable y, and what will be the value of y? It will be the y value, the horizontal line intersected along the y-axis, which is -3. So we name the axis of symmetry as y equals -3. Since we already had practice on how to identify the equations of the axis of symmetry and the directrix, we now go back to the steps in graphing a parabola, and we formally have the first example. For the first example, we have here x squared equals 12, quantity y plus 2. The first thing that we need to know is the orientation of the parabola, because the orientation will dictate the movements in plotting all the essential parts of a parabola. So, what is the orientation given the equation? Notice that x is the one that is squared, and for p, which is 12, is positive. Therefore, the orientation is upward. After identifying the orientation, we need to plot the vertex, and vertex is represented by coordinates hk. So similar, in identifying the center of a circle, we need to associate h with x and k with y. So the vertex here, hk, will be at 0, 2. There's no constant associated with x, and the constant associated with y is positive 2. When you get the vertex HK, you need to reverse the sign. So we now plot the vertex at 0, -2. This is exactly along the y-axis, and it is here at this point. This is now the vertex at 0, -2. After plotting the vertex, the next step is to plot the focus. And to plot the focus, we need a distance, and that distance is represented by variable p. We discussed last time how to solve for the value of p. Simply locate the constant multiplier on the right-hand side of the equation, or the constant multiplied to the variable not squared, which is y plus 2. After that, you simply divide by 4. So 12 divided by 4 is 3. Therefore, the value of p is 3. Now, in plotting the focus, I highlighted last time that you need to follow the orientation of a parabola. So, since we identified earlier that this is a parabola that opens upward, when plotting the focus, you're also going to move upwards. How many units? It will be p units, which is 3 units. So starting from the vertex 0, -2, we are going to count 3 units above. So 1, 2, 3. The focus will now be plotted here at 0, 1. The symbol for focus can be capital letter F. After plotting the focus, it was mentioned on the steps earlier that the next part that we need to graph is the directrix, because directrix will also use the value of p. But this time, in plotting the directrix, we go the opposite direction compared to the orientation, or when plotting the focus. So starting again from the vertex 0, -2, we now move downwards to plot the directrix. How many units? P units, or 3 units. So let's count 3 units below to plot the directrix. 1, 2, 3. It will be at this point at -5. So simply draw a horizontal line, because a parabola that opens upward will have a directrix which is a horizontal line. Now, it's optional if you want to plot a point just like this one here, but in manual graphing, you don't need to really plot a point here. The directrix will simply be the horizontal line. Now we name the directrix. So since it's a horizontal line, we use the mnemonic HOI, and which value along the y-axis it intersected, obviously here at -5. Hence, the directrix will be named as y equals -5. After plotting the directrix, the next part to be plotted would be the endpoints of the latus rectum. And in plotting the endpoints of the latus rectum, we need again a certain distance or measurement, and that will be 2p, or 2 times p, where p here was initially solved as 3. So 2 times p, or 3, is equal to 6. Hence, to plot the endpoints of the latus rectum, we will count 6 units. That will be 6 units to the left and to the right of the focus. Take note that when plotting the endpoints of the latus rectum, you should always start with the focus, because latus rectum is defined as a line segment passing through the focus. And just like what I discussed last time, the latus rectum will dictate the wideness of the curve of the parabola. So since it's a parabola that opens upward, to know the wideness, the movement should be to the left and to the right of the focus. So we start here at 0, 1, then we count 6 units to the right and 6 units to the left. So let's count 6 units to the right. 1, 2, 3, 4, 5, 6. The first endpoint of the latus rectum will be at 6, 1. The endpoints of the latus rectum can be labeled as LR sub 1. We now count 6 units to the left. So 1, 2, 3, 4, 5, 6. The other endpoint of the latus rectum will be at this point, -6, +1. Now, the label of the endpoints of the latus rectum are again interchangeable. It's up to you. What point would you like to label as LR sub 1 and LR sub 2? After plotting the endpoints of the latus rectum, we can now draw the curve of the parabola that opens upward. The points that you need to connect would be the vertex and the endpoints of the latus rectum. Then don't forget to indicate the arrowheads so that we know that the curve is extending infinitely on both directions. This is now the graph of a parabola, but we need to label or emphasize where the axis of symmetry is. So notice that the axis of symmetry is also the same as the y-axis, because when you draw a line from the focus and the vertex, they'll be exactly overlapping at the y-axis. So let me just represent the axis of symmetry as a blue broken line. And since it's a vertical line, to name it, we use the mnemonic VOOX. So we are going to use x as the variable equals to a constant whose value is the x variable that the vertical line intersected along the x-axis, which is also the same as the origin. So the axis of symmetry will be named as x equals 0. And that is how you graph a parabola that opens upward. Moving on, let's proceed to the next example. We have quantity x plus 2 squared equals negative 8 times y plus 2. The first step is to identify the orientation. Can you identify the orientation? X is squared, so your only option is it's either a parabola that opens upward or downward. Now let's check the sign of 4p. 4p here is negative 8. Since it's negative, it's a parabola that opens downward. After identifying the orientation, we plot now the vertex. So we need the value of h and k. H is initially positive 2. K is initially positive 2. Again, let me highlight that when identifying the h and k values, we always need to reverse the sign as we are taking it out of the equation. We now plot where negative 2 is, and it is here along the third quadrant. After plotting the vertex, next is the focus. And we need again the value of p. For p is negative 8, we simply divide it by 4, then get the absolute value. So 8 divided by 4 is negative 2. The absolute value of negative 2 is positive 2. Hence, the value of p is 2. To plot the focus, we follow the direction of the orientation of the given parabola. So since this is a parabola that opens downward, we're going to move below how many units? P units or 2 units below. So starting from negative 2, let's count 2 units below. The focus will now be plotted at negative 2, negative 4. Moving on, after plotting the focus, we now plot the directrix, and that will be p units on the opposite direction starting from the vertex. So from negative 2, instead of moving downward and plotting the directrix, it will now be the opposite direction 2 units above. So let's count 1, 2. The directrix will now be plotted at this point. And since it's a parabola that opens downward, it is again a horizontal line. And notice that it is exactly overlapping on the x-axis. So when we name this equation, it's a horizontal line. So we use HOY. Y equals the y value where the horizontal line intersected along the y-axis, which is exactly at the origin or 0. So the directrix will be named as y equals 0. After plotting the directrix, next are the endpoints of the latus rectum, and we need again a certain measurement, which is 2p. So 2p will be equal to 4 because 2 times the value of p, which is 2, is equal to 4. Therefore, to plot the endpoints of the latus rectum, we are going to move 4 units. Since it's a parabola that opens downward, in plotting the endpoints of the latus rectum, the movement will be to the left and to the right, starting from the focus. So from negative 2, negative 4, let's count 4 units to the right and to the left. So let's count first to 4 units to the right. So that will be 1, 2, 3, 4. The first endpoint of the latus rectum is plotted at 2, negative 4. And then to the left, 4 units to the left, the other endpoint of the latus rectum is plotted at negative 6, negative 4. After that, we can now construct the curve by connecting the vertex and the endpoints of the latus rectum. Make sure that the orientation will be following the identified orientation earlier. And then, do not forget the arrowhead. Lastly, we plot the axis of symmetry by simply making a line connecting the vertex and the focus. And that line will be a vertical line. So to name a vertical line, we use the mnemonic VOX, meaning we are going to use x variable. X equals a constant. And what is that value of x? It is the x value or x coordinate where the vertical line intersected along the x-axis. Hence, the axis of symmetry is named as x equals negative 2. Let's now proceed to example number 3. We have quantity y minus 2 squared equals negative 4 x minus 3. We first identify the orientation, and since y is squared and 4p is negative, given negative 4, then we can conclude that this is a parabola that opens to the left. Again, we start by identifying the vertex hk. H is found here on the right hand side of the equation. Initially negative 3, reverse the sign, we get positive 3. Then k is now on the left hand side of the equation. Initially negative 2, reversing the sign will give us positive 2. Hence, the vertex will be plotted at 3, 2, which is here on the first quadrant. After plotting the vertex, next is focus, and to plot the focus, we need the value of p. For p is defined as negative 4, we divide it by 4, then get the absolute value. Hence, the value of P is equal to 1. To plot the focus, the direction that we are going to follow will be the orientation, which is left. So we move P units to the left. That is 1 unit to the left. Starting from the vertex 3, 2, we count 1 unit to the left, and then this is where the focus is. It will be at 2, 2. After plotting the focus, next is the directrix. Again, we move P units, but this time to the opposite direction as the orientation. So it will be 1 unit to the right. So from the vertex 3, 2, we move 1 unit to the right. This point will be our basis where we will draw the vertical line that will represent the directrix. Now take note that when we have a parabola that opens to the left or to the right, the directrix is always a vertical line. The name of the directrix will be representing this equation x equals 4. Because this is a vertical line, so we use VUX. Variable x equals the constant along the x-axis or the integer along the x-axis where the vertical line intersected, which is at 4. Hence, the directrix is x equals 4. Moving on, we now plot the endpoints of the latus rectum. And to plot the endpoints of the latus rectum, we need the value of 2p. So 2p will be equal to 2 because 2 times the value of P, which is 1, is equal to 2. Now, since this is a parabola that opens to the left, in plotting the endpoints of the latus rectum, we're going to move up and down, starting still from the focus. So, from here to 2, we are going to move 2 units above and 2 units below. So moving 2 units above will give us this point, the first point of the endpoint of the latus rectum, which will be at 2, 4. Then moving 2 units below will lead us to this point, the other point or endpoint of the latus rectum at 2, 0. Notice again that the focus is always aligned with the endpoints of the latus rectum. After that, we can now draw the curve. Make sure that you connect the vertex, the yellow dot here, and the endpoints of the latus rectum, which is the red dots or point. And then the direction, obviously, of the curve should be opening to the left. Do not forget the arrowhead. Lastly, we graph the axis of symmetry by connecting the points, vertex, and focus. It will now become a horizontal line. So in naming the axis of symmetry, we follow the mnemonic HOI. Since it's a horizontal line, we use the variable y. And what is the value of y? It is the y value along the y-axis where the horizontal line intersected, which is here at positive 2. Therefore, we name the axis of symmetry as y equals 2. And this is now the graph of a parabola that opens to the left. Let's now proceed to the last example wherein we are going to graph a parabola that opens to the right. Since y here is squared and 4p is positive, definitely we can verify that the given equation is a parabola that opens to the right. To start by plotting the vertex, take note that h can be found on the right-hand side of the equation and k on the left-hand side. So the vertex will be 1, negative 3. It will be plotted on the 4th quadrant. After plotting the vertex, we identify the value of p to plot the focus. So 4p here is 9. We simply divide it by 4. That will be 9 over 4. But if we deal with fractions, we need to convert it to decimal so that we can approximate plotting it or graphing the focus. So 9 over 4 will be approximately 2.3. It's best if you round it off to only one decimal place so that it will not be too confusing dealing with a lot of decimal places. Now, after solving for p, we now plot the focus. And in plotting the focus, we follow the direction of the opening, which is to the right. So starting from the vertex 1, negative 3, we plot 2.3 units to the right. So since there is a decimal 0.3, we need to simply estimate its measurement. So from 1, negative 3, let's move 2 units, 1, 2, then 0.3. The focus will now be found somewhere here at 3.3, negative 3. After plotting the focus, we now plot the directrix and we now go to the opposite direction, moving 2.3 units to the left. So starting from the vertex 1, negative 3, let's move 2.3 units. Again, it will just be an estimation. So 1, 2.3 would be somewhere here. Then this is the point where we draw the vertical line to represent the directrix. Now what will be the value of the directrix? It will be the x variable it intersected along the x-axis. But since we are dealing with decimal, we can simply subtract 1, which is the value of h, which is also the x-coordinate. And since we moved horizontally, we need to subtract on h, which is the x-coordinate. And what are we going to subtract? The value of p, because this is the number of units we moved from the vertex to the left. So that will be 1 minus 2.3. The equation now for the directrix will be x equals negative 1.3. Moving on, we now plotted the endpoints of the latus rectum and we need the value 2p. So 2p will be 2 times the value of p, which is 2.3, and that is approximately 4.6. Now, since this is a parabola that opens to the right, in plotting the endpoints of the latus rectum, the movement will be up and down. So starting from the focus, 3.3, negative 3, we now move 4.6 units above and below. So notice that we will only move along the y-axis or only vertically. That's why all of the points will have the same x coordinate but different y coordinate. So starting from 3.3, negative 3, let's just approximate 4.6 units above. So let's count 1, 2, 3, 4, 5. 5 is here, so 4.6 is somewhere in between 1 and 2 along the y-axis. Somewhere here. So since again we moved vertically, the x coordinate will not change. It will still be aligned on the focus. That will be 3.3, whereas the y coordinate will be changed in such a way that we added 4.6 to negative 3, which is the starting point where we move. So negative 3 plus 4.6, which is our movement upwards, the result is 1.6. Hence, the first endpoint of the latus rectum is plotted here at 3.3, 1.6. Let's now move 4.6 units below the focus. So starting from here, we count 4.6 below. 1, 2, 3, 4.6 somewhere here, and that will be at 3.3, negative 7.6. Notice again that the x-coordinate did not change. It's the same as the x-coordinate of the focus and the first endpoint of the latus rectum because they are aligned vertically. What changed is the value of y. From negative 3, we subtracted 4.6 because it is a movement downward. And when you move downward, it will be associated with the operation subtraction. So from negative 3, we move 4.6 units below. It's the same as negative 3 minus 4.6. The result is negative 7.6. Hence, the coordinates of the second endpoint of the latus rectum is at 3.3, negative 7.6. After that, we can now draw the curve by connecting the endpoints of the latus rectum and the vertex. Make sure that the parabola opening is to the right. Then, do not forget the arrowheads. Lastly, we plot the axis of symmetry by connecting the points vertex and focus. And that is the same to a parabola that opens to the left in the previous example. It will become a horizontal line. So, it will be y equals a constant. What is that constant? The value of y, which the horizontal line intersected with the y-axis, which is here at negative 3. Therefore, we name the axis of symmetry as y equals negative 3. Kindly disregard the close parenthesis. And this is now the graph of the given equation. And that is how you graph a parabola. I hope at this point it is somehow clear how to graph a parabola. And that concludes today's video. See you again on the next one. Bye!